Alright, so from today we're going to start doing the gradient and the direct proportion. Okay? But before that, let's do a revision. Now, when we talk about linear relations, we always have this format. And then yesterday we talked about this. This one is called gradient and intercept form. Okay? So why it is called gradient and intercept form? The reason is M is called gradient. Okay? Now, gradient, we use gradient to tell whether the line, what is the function? What is
positive or negative?
Positive or negative. So that represents the line is going
Down.
up or going
Down.
down. Good. Alright, so that is the gradient. And also the gradient tells you how steep your line is. The greatest gradient will give you a steeper line. Okay? So that is the function of the gradient. So C is called Y-Intercept. That means where the line cuts on the y-axis. So if that is plus 2, so the line cuts y-intercept, cut the y-axis at 2. If that is take away 3, so the line cuts the y-axis at negative 3. Alright, so this is the y-intercept. Now today let's have a look at something different. Okay? Alright. Now let's start from a real world question. Now water is poured into an empty tank. It takes 3 hours to fill the tank with 6,000 liters. Actually, that is the questions here. Alright, you can have a look at your worksheets and for the first one, real world questions. Okay, now what I want everyone to find out first is, could you please write down what is the rate at which water is poured into the tank? So firstly, you have to think, what does rate mean? We learned that last year. Now please do that first by yourself. Okay, now what is rate? What is rate?
The ratio.
The ratio, but it's a little bit different from the ratio. Now some people mention a ratio that's very, very good. Okay, now let's start from the right. Okay, let's start from right. For this question, we can say it takes 3 hours to fill that 6,000 liters. So can we say that is 6,000 liters and in 3 hours? Now, the rate should be alright, so we know 3 hours, 6,000 liters. Now how about 1 hour? 2,000 liters. Okay? Now, we call this is rate. Something per hour. Okay? This is a rate. Rate is something per hour. So 1 hour is a unit time. Okay? Now, could you give me some other unit of the rate? We can say something per minute. Okay? Yes, 1 minute. And we can have something per second. Good. So in science, you always do that. Meter, we always use meters and S. Did you see that before in the science class? Yes? Alright, that is 1 second. How many meters? Okay? And then we call that speed. So speed is kind of rate. Okay? Speed. And you can always see that in your real life. For example, could you tell me the common speed limit you can see on the road? 60? 80? Alright, they are all right. Okay? So if you see 60, what does 60 mean? $60 or 60 meters? Your car is very slow, right? 60 meters. So this is 60 kilometers
Hour.
per hour. Yes, you can see. So we always write that per hour, 1 hour. All right, per hour means 1 hour. So it's easy to find the rate. Okay, so 1 hour, 2,000 liters. Okay, all right. Now, the next one. Could you please try draw the graph of the volume versus time? All right, so I explain this to you. T is the time. Time means less than and equal to 3 hours, and then more than 0 hours. Okay, all right. Now, could you tell me which one is the x-axis, which one is the y-axis? Which one will be changed according to which one?
The liter will change according to the hour.
Oh, some people say the amount of water will be changed according to different hours. Is that correct?
Yeah.
Or the hours will be changed according to different liters.
No.
So 1 liter, that will be 2 hours. 2 liters, suddenly 3 hours. Which way is correct?
The
The
first
first
way.
one.
The first way. So your volume will be changed according to different hour. That makes sense. Okay? So your time is x-axis. And then your volume is the y-axis. Okay. Now I would like everyone to establish this Cartesian plane first. So do not draw the graph, just build up this, draw the Cartesian plane. Now I want you to use this area efficiently. Okay? Is that efficiently? No. Alright, don't draw this. You have that space. Alright, that large space. Don't draw that here. And then later you cannot find your scale. Okay? Alright, think about this and start doing that. Okay. Now, let's look at this one. Now, this one is from one of the students, but a lot of people do the same thing like that. I want you to think, when we establish a Cartesian plane, what is the purpose? Why do you need this Cartesian plane? No, because Mr. Huang asked you to do that, so you have to do that. The purpose is we want to use graph. Now, if I just read the questions, sometimes I have no idea. For example, after 4 hours, how much water do I have? 6 hours, 10 hours. I don't know that. So if I can draw the graph and I can see the change of the water, does that make sense? All right? Okay. Now, for this one, some people say this is x. Just now I said x is the time, and then y is the volume. Now, you draw x. This means that is a positive. This is the negative. Do you need negative?
No.
Why?
Because the
Yes, you cannot have negative 1 hour. That does not make sense. Alright? How about volume?
no negative.
It's empty.
Can you have negative 2,000 liters? No. Do you need this part?
No.
No. Okay, now I want you to do some corrections. Think about that, okay? You don't draw that you don't need. Okay, now let's have a look at this Cartesian plane. It's a little bit small, right? But that's fine, alright? Now, for the x-axis, we have 0, 1, 2, 3. Is that enough?
Yeah.
Do I need 4?
No.
Why?
Because that you
Why I don't need 4? Who can tell me why I don't have to write 4 here? Very good. It's set 0 less t is more than 0, less than 3. So 3 is enough. How about my y-axis? How can I decide how long is that? Is that enough?
No.
Why is not enough?
Oh,
what? Yes, you have 6,000 liters. So you have to think about 6. Now, and the other thing we have to think is, do I go 1,000, 2, 3, 4, 5, and 6,000, or something else? It depends on you. It really depends on you. And also, the grade. Alright? So I use one grade as 1,000. I use one grade as 2,000. It all depends on you. I will not give you a very fixed answer, so you should do that. It's no fixed answer. Okay? As long as you can accommodate all the numbers you need. That's correct. We can see these students got 2,000, 4,000, and 6,000 each gap. Is that correct? Alright? And also, do you need to show 1,000? Do you need to show 1,000? Why? Because 1 hour is 2,000. That is, I think that is the minimum. So you don't have to do 1,000. So if that is 1,000, that is 30 minutes. Okay, half an hour. So you don't have to show half. So 2,000 is enough. Okay, 2,000 is enough. And can everyone tell me what's missing on this graph?
0.
Very good, 0. Now I want you to check yours. Did you write 0?
Yeah.
That is very important. And also, everyone, I told you just now this one is the x-axis. This one is the y-axis. Now when you label, you cannot label x and y. What do I have to label? What is the x-axis? What that represents? Times. So you need to write t, or you can say hour. Alright, t hours. So this is the correct labeling in the real world questions. Next one, for y, that should be the volume, liters. Okay, like that. Okay, good. Now I want to show another one. And some people said, can I write like this? Okay, it's not very... Now you can see that is very clear. X-axis and the y-axis extended very well. And I can see there's 1,000, 2, 3, 4, 5, 6, 7. Now can you tell me what is the advantage if you write more here, not 2,000?
It's more clear.
It's more clear, or it's, we can say it's more accurate. Okay, it's more accurate. Now, she just asked, can I write the times like that here, not over there? That's fine. Alright, if you write t here, hours, that doesn't matter. So if you write t here and write volume here, that's fine. As long as you label, clearly label, that's fine. Okay, we have 0, errors. Okay, good. Now for mine, I probably set up that here. Okay, so this is my volume, liters. Okay, so this one is my 6,000 liter. Now you see, I start from here. I didn't start from 0. Can you tell me why? A lot of skills, everyone, to make sure you do the questions quickly. I started from 6,000. Why? Why I didn't start from 0? Yes, very good. I make sure I have enough room. If I start from here and going down, we have enough room. Okay, so 6,000. So okay, that's fine. So I can do 4,000 here, 2,000 here, and then no, it's not enough. Okay, it's my 0. Now after you set up this axis, you have to make sure each gap you have the same amount of scales. So that is 2000, 2000, 2000, so that's correct. Okay? Alright, now let's draw this x-axis. So for x-axis, I have got enough room, and I can only draw 0 to 3. So I probably do 0, 1, 2, okay. 3. Okay, I make sure that it's a 3 grid, 3, and 3. Now, can you tell me what is the purpose of making 3 grid 1 hour? Can I do 1, 2, 3 here? Yes, no problem. Okay, it's no problem. But why I do 1 here, 2 here, 3 here? Yes, more space and easy to see that. Okay, it's all about the accuracy. So it all depends on you. As long as you can express that function or that relations clearly, it doesn't matter which way. Okay, but you want to use all the space and then to make your graph very, beautiful. Okay. Now let's start doing that. If I need to draw the graph, all right. If I need to draw the line, what do I need to draw a line? Coordinates, very good. How many coordinates? 2. 2 points. Now, what are the 2 points we normally use? X-intercept and Y-intercept. Good. Okay, now I would like everyone to find the X-intercept and the Y-intercept for this.
0, 0.
Something 0, 0?
Yeah.
Why do you think that's 0, 0? So start, if I start from 0, that means 0 hours. How many liters are there in the tank? 0, nothing. So 0, 0 is 1 point. Very good. How about my next step? So this one is my intercept. This is the origin. So we don't have any x-intercept or y-intercept because that is the origin. How about my next point? Where's my next point? She said that it's 3 and 6,000. How did you know that? Because that is 3 hours, 6,000. Okay? Alright, now I would like you to plot this graph. Draw the graph now. And also, can I use 1 hour 2,000? Yes? Good. You can also use that. You found the right. Okay. Is my drawing correct?
No.
Why it's not correct? Can I go over to the negative? No, right? Because time cannot be negative and the volume cannot be negative. So this part is not correct. How about this part? It's all over because you only draw less than 3 hours. So we don't need this part. Okay, now this is called a line segment. So for the real world problems, normally you will draw the line segment, not the straight line. It's different. Okay, alright. that, I would like everyone to find the gradient. Alright, find the gradient. Now we have used two ways to do the gradient. You can use y steps. You can draw the y steps and x steps, or you can use a formula. y2 take away y1 and y2 take away y1 over x2 take away x1. Okay? Alright. But which point is easier to be used? 0, 0. Good. So use 0, 0. Right? So because easy to be used. Alright, gradient. Let's have a look. The gradient is m equals y2 take away y1 over x2 take away x1. Now I have already written down this one here. So this is my, we can say x1, y1, and this one is x2, y2. Okay? Or some people said this is x2, y2, and this one is x1, y1. It doesn't matter, you have the same answer. But which one is easier? If this is x2, that's easy. Is that correct? Why?
Because that's minus 0.
Yes, because they're all minus 0. You will have the positive number. Okay? Alright, so let's do that. y2 is 6,000. Take away y1 is 0. Over x2 is 3. Take away x1 is 0. So you have 2,000. So this is a gradient. What can you find this 2,000? What do we do for the 2,000?
1 hour.
This is 1 hour. So this is the rate. Can you see that?
Yeah.
So the gradient actually is the rate. Oh, I'm sorry. I told you the answer. Oh, I told you the answer. Okay. Now, anyway, continue. Now, if that is the gradient, can I write the rule for V? V equals
Grade.
V equals
M.
what is the value of M?
2000.
2,000 and T. Alright, because M is 2,000 T. Because T is the axis. That is the relationship.
Whatever is like on the x-axis, that's what the action is.
Yes, very good. You got that. So this is the rule. Now, could you tell me, for this one, I have got my y-intercept plus what?
0.
Plus 0 because that intersects at the
0.
origin. So, if I plus 0, can I leave that?
Yes.
Yes. Very good. So this is the way we can find the rule. Okay, now we want you to find out the next question, question D. The volume after 1.5 hours. How can I do that? What is the volume? It's not difficult, right? So how can I do that?
2000 times.
Just 2,000 times
1.5.
1.5. Or I recommend you do multiplication sign between the number. Otherwise, you will have the misunderstanding of the decimal point. Okay, so the answer is 3,000 liters. And also, can I check my answer from the graph?
Yeah.
How can I check that, whether your 3,000 is correct? So 1.5, so that should be here. But if I go up, and then to here, that is 3,000, alright? But what is the disadvantage of this way?
No accurate.
It's not very accurate. Good. You can see, if you draw that not inaccurate, this is not exactly 3,000. But we can estimate. We can estimate your answer is correct. Alright? Good. Now, the time fill 5,000 liters. The time, what is the time? And then you can fill 5,000 liters. It's not very difficult. We just substitute that here. 2,000 T equals 5,000. T equals. So that is 2.5 hours. So after 2 hours and a half, and then you will have 5,000 liters. Okay, now let's draw a conclusion here, right? So I want to turn that off. Okay, perfect. I need this one. Now, if we have the relations like y equals mx, I want you to write that down. Okay, y equals mx. So for these relations, do we have X-intercept or Y-intercept? There's nothing after that. Okay? So if you have y equals mx straight away, we call this direct proportion. And you can understand that easily. That's directly proportioned each other. Okay? So if you have 1, so that is 1 loss of x. If you have 2, that is 2 loss of x. 3 loss of x. Straight away. So we call that direct proportion. Alright? And also, for direct proportion, the line, what is the typical features of the line? The line passes through
0.
0, 0. Good. Origin. And also we can see if the line passes through the origin, this is a direct proportion. Alright? It's direct proportion.